Welcome to the Flux Dev Meeting, January 14th.
Hello, everybody.
Hello.
Um, so let's get started. I guess I can give a few updates. On my end, I'm working on Helm 4. We merged the source controller pull request, so bumping to Helm 4 there was no issue. I tested it with in many setups, and yeah, there's no new features, of course, on source controller. A new feature that would come with Helm 4 would be Helm chart API v3, but they didn't release it yet, so nothing to do in Source Controller. Now I'm working on Helm Controller. I already have a compiling version of all the code and tests in my machine, uh, but not all tests are passing locally, so I'm working on investigating why they don't pass and fixing when possible and documenting breaking changes when that's the case. Uh, I guess it's going well. Helm 4.1 will land uh 1 week from now exactly. So I already have PRs for the release candidate to experiment if the CI passes in the package repo and source controller. The CI is passing fine. Um, and then 1 month after Helm 4.1 releases, comes Flux 2.8. With Helm 4 support. Um, on the cosine V3 side, Lee gave me some updates. I think he did confirm that um, cosine V3 actually uses some advanced OCI 1.1 standard API for storing signatures and falls back to a tag when the registry does not support it. So I guess we're fine. Uh, we can say that only old registries will be a problem for large setups in image reflector controllers storing too many tags in disk. So if you upgrade to a registry that is more modern and supports OCI 1.1, then Cosine will be able to do this more efficiently without tags and therefore without filling image reflector controller disk. Um, he also gave me some updates towards the upgrade itself. He figured out how several configuration knobs work and also how non-working configuration setups can take place, like what you should not do. So basically, he made some substantial progress since last week. Um, yeah. Oh yeah. Also in Helm controller, the feature that we need for custom health checks through cell expressions, like we implemented in customized controller last year. Um, we discussed this last week. And I opened a pull request and it's already merged in Helm. So Helm View 4.1 will have support for custom case status readers, which is what we need for implementing the cell-based health checks in Helm controller. Also something that can happen in Flux 2.8, but there's like 4 features that we want to implement after Helm 4 and Helm controller. Maybe we're not gonna have time for all of them. I'll see what I can do. So the 4 of them are server-side apply, right? It's one of the major improvements of Helm 4. That's the one we want to prioritize as the first one once Helm 4 is merged. So we can, so basically without supporting server-side apply in Helm controller, what server-side apply will look like with Helm 4 and Helm controller will be um you cannot like if Helm controller is going to install a release, that would be legacy behavior, client-side apply. But if Helm controller is to take over a Helm release which you installed through another method like the Helm CLI using server-side apply, which is the default for Helm 4 CLI, then Helm controller will be able to pick upgrades with server-side apply. So Helm SDK has these fields for server-side apply, which are install is just a boolean. It's either server-side apply or not. Defaults to true in the CLI. For upgrade and rollback, server-side apply has three values: true, false, or auto, right? Which means pick up whatever is in the release, right? So if you installed a release with server-side apply, which is the default for Helm for CLI, upgrades with auto, which is the default as well, will use server-side apply, of course. But if you installed a release with Helm 3, for example, and then Helm controller or the Helm CLI the Helm 4 CLI is going to perform an upgrade on that release that was installed with Helm 3, the default behavior of upgrade, which is auto, will be use what was used in the during install, what's in the storage, the release storage in the cluster. So that's Helm 4 default behaviors. Default install is server-side apply. Default upgrade is auto. So in Helm controller upgrade to Helm 4, the first pull request is simply setting server-side apply to false in installs and upgrades and rollbacks to auto to, of course, support what what what's in the release already, right? But then once we merge Helm for pull request and Helm controller, then we can implement server-side apply as well as an opt-in feature for install and an upgrade and rollback. Like you can have, I don't see why not give full control over those flags. It's literally like install with Boolean, rollback and upgrade is a three value enum, true, false, or auto. So we can basically introduce um, fields in the Helm release API, action specs for that, just like we have a bunch of fields, similar fields for all the actions out there. It will be just one more, like server-side apply, and that's it. That's the one that is guaranteed to ship with Helm with Flux 2.8 server-side apply. We're going to implement Helm 4 and those flags in the spec.
There's one
Then,
question here.
cool.
Sorry to interrupt you. I'm Anshuman. I have one question here. In Flux 2.7, how is it different when we have installed, for example, using Helm 3 CLI, and then Flux takes over? It still does, I think, server side apply, or no?
No, there's no server-side apply in Helm 3 or Flux 2.7 at all.
So it picks the storage, the secret basically, and then compares, or
Yeah, Flux. So I guess this is two questions. First question is there server-side apply at all in Helm 3 or Flux 2.7? No. Helm 3 does not support server-side apply in any form. Flux 2.7 Helm controller does not support server-side apply in any form. Second question
Mhm.
is what is the storage for, right? The secret storage. For drift detection. So this is an opt-in feature we have in Helm controller, object level feature. It's a field that the drift will be a check between the cluster state and the storage. not what's coming, like it will not like template the chart again, fetch values from secrets and config maps. Nothing of that will happen.
Mm.
Drift detection in Helm controller is literally for comparing. Like we literally open up the storage. We see everything that's in there and compare against the cluster state. The source is not looked at.
Okay.
And there's no server-side apply in that at all.
Mm.
Like our drift detection code is like a sort of a copy of what Helm does for upgrades and rollbacks. Uses the same client, the same weighting mechanisms. It's like basically we literally use the bits offered by the Helm SDK to do what it does as a custom action that is not exposed in the actions package of the SDK, right? Drift detection is like a Flux only action that builds on the smaller abstractions the Helm SDK offers, and none of that is server-side apply. So server-side apply is a Helm 4 and only feature, and Flux 2.8 confirmed only feature. Like that's the first one that we're gonna implement once the Helm 4 upgrade PR is done. Then we have 3 other features that are pretty cool that we can implement if we have time, which are maybe in order of priority, reduce the time to recovery, mean time to recovery on failed deployments. That's a feature we have just implemented we actually improved in customized controller from 2.7 to 2.8. So in 2.7, we have this feature where if the revision of the source changes, customized controller can, with a feature gate, an opting feature gate, it can cancel health checks if it detects a new revision has arrived. So let's say you customize controller is applying something and you change something in the source in Git, and it's taking a while for the reconciliation to complete because maybe you made a mistake, actually, typo, and because of that typo, the health checks of customized controller over the applied resources are not completing or going to timeout. Then you don't have to wait for the 5 minutes default timeout anymore. After this feature we shipped in 2.7, you opt in into this feature gate, and the health checks will be immediately canceled once a new reconciliation is detected, once a new revision of the source is detected. Now, in Flux 2.8, we evolved this feature to support any event sources for customized controller. That means not only a revision change, but also a Flux reconcile KS command, or a referenced config map in the post build substitution, um, or even the config map in for workload identity to remote clusters, or basically anything that can trigger a reconciliation of a customization in customized controller now is detectable and can cancel health checks. That's the feature we implemented in the customized controller. And Helm 4 introduced support for the same thing. Therefore, once we merge Helm 4 upgrade, we can implement the same in Helm controller as well. So that would be my top priority after server-side apply. Then we also have inventory tracking in the status of Helm release. So like customized controller has always kept track of the applied and managed objects in status.inventory, right? That feature is not available in Helm controller, Helm release API. we want to implement that. That's not something that depends on Helm 4. It can be done today, but of course, our priority is Helm 4. We're only going to implement that once Helm 4 upgrade PR is merged. That's useful, for example, in Flux Operator in the web UI, right? Like, and also in the Flux CLI, in the Flux Operator CLI, like there's many places where we open up the Helm storage to expose and enumerate the objects that the storage contains, that the Helm release contains. So that will go away everywhere. Like Flux CLI doesn't need that anymore in Flux 2.8 if we manage to implement this feature. Flux Operator CLI, Flux Operator Web UI, all of those tools that have to go through the cumbersome work of opening up the storage, like parse base 64, because just it's um I mean because once is not enough, right? Helm had to put another layer of base 64 there, and compression, and then you have to go through every resource, check which ones are cluster scoped and which ones are not, because for the ones that are not and do not have a namespace field, you have to default to the release namespace. So very complicated code for looking up at the inventory of a Helm release. This code will go away everywhere once we expose this. Once we write this code only once in Helm controller. This code is already there for drift detection. So drift detection already does that. We'll just like refactor this code to reuse it for inventory tracking as well. And then uh, last but not least, the fourth feature that we could do in Helm controller if we have hands for it until the deadline is custom cell health checks, as I mentioned earlier. Helm 4 has now support for it after the pull request I opened and merged in Helm this week. Helm 4.1 will have it, which is what we're waiting for Flux. Yeah, so very good Helm controller improvement in Flux 2.8. We may or may not have time for all of them. Let's see. Yeah, I guess updates from me. That's it. So I guess we can open up for updates from anybody else on the call. So questions or any other topics. I see Adrian is here today. What updates do you bring?
I actually have a question about the Helm 4, based on what you just described, that was very enlightening. I did not understand all of that. I kind of assumed that we already had a server-side apply wrapper around Helm controller, but it's not the case.
Not at all.
So my question is, what will happen today if someone has upgraded to the Helm 4 CLI and is running Helm upgrade commands and rollback commands and doesn't have awareness of this transition to server-side apply in Helm 4? Will Flux take the release back over successfully on the next reconciliation, or will there be a problem?
2.8 will.
2.8 will, but assuming that we're still running 2.7, it's going to be a problem, right? And it's Helm that broke it. It's not Flux's fault.
I get, yeah, totally.
Okay.
Uh, I guess it can depend. I mean, server side, if in my understanding, which may not be,
I may have
uh,
already done this and I haven't seen a problem, just to be
yeah,
tra
exactly. Like depends on what's inside the chart, what the chart is doing. I guess what server side apply means is when you're opting to server side apply, what you're saying is you are okay with sharing managementship with other tools, right? Uh, Server-side apply is the ability to specify a partial opinion on the resource. You only have an opinion on the fields you send to the API server on a server-side apply.
And that's
So
accounted
you,
for with managed fields internally in
yes,
Kubernetes. Right. Okay.
yeah, exactly. Like the managed fields in the metadata field are for that those tracking purposes, like to know who is the owner of each field. And yeah, so that's my understanding of server-side apply. Like it's a way to specify a partial opinion on the resource. So uh, I guess it basically depends on the chart, right? What's in there? What are you actually using to,
Okay. So the advice to
yeah,
users at this point is still to keep an eye out if you are upgrading to Helm 4 and possibly to hang on and just keep your Helm 3
yeah,
CLI for now until 4.1
yeah,
or until 4.1 and Flux 2.8 rather.
yeah. Um, yeah, so I guess that's something that Flux users should really be aware. Like Flux is known for the best integration with Helm, which means running all the Helm code, right? All the SDK, and we don't have it in 2.7. So if you're using Helm 4 CLI to do stuff, uh, as a Flux user, I guess you should know.
I think this is part of the broader,
Yeah.
everyone should understand what Semver is, and if a major version bump comes, you better keep your eye out for what
Yes.
it means.
Yes. Yep. Definitely. Yeah. You're right. Cool. Any more questions about Helm?
Yeah, I have one more. I actually raised an issue in our Slack. I don't know if you had a chance to read it, but with the new watcher change, it's an interesting behavior. I think maybe intended as well is when you have a Helm release, referring to a config map from where values come from, right? And if you have a same Git commit, which also upgrades your value as well as chart version, the it reacts immediately, and old chart takes up the new values which are coming from config map. We noticed this because for one of the values it was incompatible with old charts, and our release was then stuck until the timeout happened basically.
That's something I'm gonna fix very soon, as I mentioned. You're not gonna be
Okay.
stuck for the timeout anymore, right? It's the reduce mean time to recovery feature where I cancel health checks once I detect a new reconciliation. So, uh,
I see. Now
yeah,
that would be really cool.
that's something that like, uh, it's probably a pain for most Flux users for years. And I guess nobody had the maybe curiosity to investigate a solution for this. And recently I found one. Uh, yeah, I should have been implemented years ago, but now it's coming finally. So yeah,
Hmm.
I think everybody suffers from that, right? Like you make a mistake on the release and then you're stuck for the timeout. The
Yeah.
only way to fix that is deleting the Helm controller pod, right?
There's another way to fix this, but it's fiddly and requires a lot of attention and care, where you make an estimate of how long the timeout actually should be, and you set it shorter than the interval. And you do this on a case-by-case basis, where certain customizations, the timeout could be, too short, and then you're rolling things back, and it's fiddly. It'll be much better um, when we don't have to do all that.
Yeah, yeah. Yeah, this
But
improvement is much
that would
needed
be
by
cool.
everybody.
That would be cool to not wait for a stuck state. But my question is,
Yeah, no, your question is about something else, right? It's about two reconciliations being triggered by an update in the value inside a config map, reference config map, and
yeah,
also the version of the chart, right?
yeah, it will always happen basically if that will be the case, right?
Yeah, yeah. That's because we now have and you said you're also using the feature of watching the secrets, right? The
I
to
mean,
react
no,
react immediately or not?
yeah, we have the watcher enabled, so reconcile watch enabled in our config
Yes,
map.
on the config map, right? Yeah.
Yes.
So yeah, basically you now have two event sources. What's happening is changing the version. So how do you change how is your Helm release YAML? Does it use spec.chart or spec.chart ref?
It uses a spec chart um, ref, I think, with version. Let me quickly see.
No, the
One
ref doesn't have a version. If the version is on the Helm release, is spec.chart.
Yeah, then it's some chart. It has the version. I specify what version I want
The version on the Helm release, right?
on the helm release. Yes.
Yes. So you change in even if it's one commit, what you're doing here is you're changing uh the Helm release object and also the watched config map. Those are two events, right? Both will trigger reconciliation. And the problem of if they happen very close, they wouldn't then you wouldn't observe two upgrades. You would observe just one because um no wait.
It will try to
Uh,
pull the chart, the new chart, I think, right before it will kick out
the
anything.
reason trying to pull the chart is not like what's happening is Helm controller triggers reconciliations of a Helm release based on two event sources in your case.
Mhm.
An event source that changes the Helm release object itself, the version,
Yes.
and the other one, the config map. And
Confirm
if
up.
they
Yeah.
are too far apart, like too far apart, I mean, not like it could be seconds, but basically like it's because you have two events. You have two upgrades if they are not very close. And that's because the controller runtime, which is the library that we use to build controllers all across Flux, has the queue, right? And the queue I think it's actually only the latest queue they have. So maybe I don't remember not right now if Flux 2.7 has the version of controller runtime that implemented the priority queue as the default queue or not. Uh, but that's a feature from the priority queue. Like so in the basically in the most recent versions of controller runtime, they now have a different default queue which is able to merge together reconciliation requests for the same object. So um, if let's say your Helm release is being reconciled right now, then in the meantime, two events happen that request a reconciliation for this Helm release. Instead of finishing the current reconciliation, reconciling one more time, and then a third time, that will not happen with the priority queue. The priority queue will merge the two requests that are on the queue together, like basically dedupe, right?
Mm.
And uh and yeah, only one reconciliation will happen immediately after the one that is already happening instead of two. Uh, but that's only like that's only in the most recent versions of controller runtime, which I don't remember right now if it's already in Flux 2.7 or not. But it will definitely be in Flux 2.8. We're gonna upgrade controller on time as always do, and all the other core dependencies as we always do for the Flux release. And with that, if it's not already there, it will be. The priority queue will be the queue used by Flux
No, we
on.
noticed this in Flux 2.7, so I think it's not there yet. Yeah.
But also so this is one thing. Another
Mm.
thing, as I said, is if let's say you have two event sources here, right?
Yeah.
Um if they happen like if so uh if they happen more than a few seconds far apart, they will be two upgrades anyway. That it's basically the time it takes for everything that causes a reconciliation on the Helm release to happen and be observed by the controller. So you said, what's the order where the
First,
reconciliations are
the
happening?
first the values are picked with the old chart, and then the new version of chart with new values. So the values are picked immediately, but the chart versions takes a little bit of time.
Right. Because so I guess updating I so you're saying the customization applies the config map and the Helm release at the same time, right?
Yes,
Is the same, sorry, is the same customization that applies both things, right?
it's the same customization. Yes.
Yeah. So it kind of makes sense to me because applying the config map is super fast, and then Helm controller immediately sees it and boom, reconciles the Helm release. So the Helm release sees the config map update. The Helm controller sees the config map update much faster, and then later
Yeah.
sees the other one.
Later, the other event source kicks in.
I guess we don't
But
have an easy solution for that.
yeah, we don't. But is it an intended behavior? Is it not sort of a? I know from the current implementation, you are thinking of these as two states, but it is sort of an intermediate state for 1 second, right? Should we not debounce that from the framework itself? I would argue, as there are in other frameworks, right? That you don't react on intermediate states or incomplete
No, no,
states.
that's there's no easy way to do that. Basically, what you're saying, customized controller has to understand what it's applying. It has to know that it's a config map, and it has to know that it's a Helm release, and it has to know that both are connected. And customized controller, the one that applies both things, has
Mm.
to do the right thing. That's not an easy thing to do. I don't have an easy solution for that, basically.
No, but this will be an issue. For example, if let's say the new values are not compatible with old schemas, right? You will always have one intermediate failure, which might be resolved quite quickly with your new change in 2.8. But you will
Yep,
always have one failed or I don't know incompatible state if the values are not compatible.
yep, probably. Like I basically, I mean, we can invest time and see what we can do about this. It's a valid issue. I just don't have, right now here a good answer for like a good solution for it. I don't like it's hard for me to imagine a solution for this. I'm not saying that is not a problem. I'm saying that yeah, that's something that would be probably appreciated by a lot of people to be fixed, but if you have time and you want to investigate how the controllers work and want to propose a solution, we would love it.
Yeah, yeah, no, sure. I just thought maybe it's just something. Yeah, it seems like everyone will face this.
Yeah, yeah, probably, and there's no, I can't imagine any trivial solution for this.
Mm.
So this needs investigation. This needs sit down time, read code, think, propose. Might be a big change, which will require probably an RFC influx. So yeah, somebody has to sit down and work on that. Uh, if you have the time, please.
Yeah.
do, and we'll be happy to review suggestions, RFCs.
But there's one before we let you go. I don't know, one more solution that we were trying before this, before we had watcher change. How we were doing that is we were making customized controller aware that these are one change. How we were doing that was we're using customize config by name reference, right? And we used to generate config map using the same customized build. And then a random suffix used to change in the Helm release object with the same customized build, which used to update the config map. Now we did not face this there, except very rarely we also see two upgrades there, which I cannot explain why that happens. Because in that case, the same customized build creates one config map with new suffix and also updates Helm release object to new suffix. Why would you have one? Sometimes, very rarely, we have seen like 3 or 4 times now a trigger which does the same thing, basically picks the new config map but picks the old Helm release version, even though it is not referenced in its Helm release manifest at all, because that was an old suffix. So have you seen this happening to anyone? Has someone else faced this? I'll in the next one maybe come back with more logs and more root cause analysis. But yeah, it's something very strange that me and Henrik here, we have been working with that and we faced.
Yeah. Um, I don't have an answer right now.
Okay.
Yeah.
But just to add there, Henrik here, the solution to this would obviously be to just get rid of the config maps, put the values directly in the Helm release, and there you go. You have like your single source of truth basically for your Helm triggers.
If you want to avoid a distributed solution, which involves maybe customized controller communicating with Helm controller, right? To say, skip this one, the next is the correct
Mm.
change.
Yeah. Yeah, that's the path we are
Impossible.
thinking here.
Right, that's what I'm saying. Distributed systems are very hard, and it doesn't do that currently. That would be a huge major change.
Yeah. That's not gonna happen.
No, I think what he means is that we will remove the values from and put the values directly in the Helm release object. So we will do the computation.
Yeah.
Yeah, exactly.
Yeah. Yeah, you can try that. Like
For users, that's a change they can make, yeah. But for the API and the
Yeah,
Flux controllers to solve this problem without forcing a user change.
no, I understand. Yeah.
yeah. Yeah, like the options you have is see what the API offers. I don't see a way to solve this on the code side easily, at least. Or when I say easy, I don't mean trivial. I mean not drastically changing the design of the controllers, which
Okay.
is
I mean, it's worth a
the
discussion. There's an issue open. We will try to think of how we can maybe solve and maybe suggest a couple
yeah.
of
I
things.
mean, so maybe it's worth trying to identify exactly which events are triggering the Helm release. Is it really the config map? Is it really the because there might be one more, like because in the when you're using spec.chart where you specify the version of the chart, what Helm controller does is render generate a Helm chart object. Um, so it it basically so what happens is like on one side what happens is you update the field of the version in the Helm release. The Helm controller will see a generation change of the Helm release because of that field change. Then it will reconcile the chart first, the chart object, which means updating the version on the underlying Helm chart object. It should, obviously, I'm pretty sure that I never looked at that part of the code, but I would be really impressed if, oh, yeah, yeah, because I think you might be getting three. Yeah, I think you might be getting three reconciliation events because the Helm controller watches the Helm chart object that it creates, right? I don't see how it would not like. So it's true. It's very likely that it's true that the Helm controller will apply the new spec of the Helm chart object after your version change. It will wait for this object to reconcile in source controller, and then it will move on with the Helm release reconciliation. But that does not eliminate the watch event that this will produce, right? I think this is the case. Like I can do some quick tests to verify that, but that I think that's correct, right? Like I don't see how uh like because mm, yeah, maybe it's only in the ref. Yeah, you don't even let me check real quick here. You guys may discuss something else while I look at the code if you want. I'm curious now. Um,
Yeah, hello guys. I just wanted to mention one thing. Yeah, hi, this is Adrian. Adrian here.
hello, Adrian.
I've been missing these calls because I was busy with meetings and so on. But just to let you know, I'm working on this auto thing. I struggle a bit. I have to reach out to the auto guys in order to know how to approach this. But yeah, I'm I'm on my way. Yeah,
Nice.
yeah.
Thanks for the update.
Yeah, no problem.
So, Helm chart. Yeah, so in the Helm controller, we have a watch for Helm chart objects. When we get an event, we list all the Helm release objects matching the source index key, which we index with, yeah. So if it has chart have and does not have chart template, we do one thing. And if it doesn't have, oh yeah, yeah, we watch it. Yes, maybe we shouldn't. But yes, so what happens is, uh, you change the version. Helm controller sees this change. It renders the new spec of the Helm chart, applies, waits for the reconciliation, then moves on. That also triggers another reconciliation, if I understand the code correctly. Like when and that's not that doesn't trigger an update. Yeah, I mean because uh, a Helm release upgrade is a big deal, right? But because of the way Helm controller works, it doesn't trigger like if it a Helm release with default configuration, it will see the second reconciliation, and it won't do anything, right? Because that's how Helm controller works. It doesn't actually run an upgrade unless you force, right? So this explains everything. Like in a Helm chart, in a Helm release that uses spec chart, which is a template for a Helm chart, uh,
Yeah.
you get two reconciliations, right? You change something there. You actually you change something in the template. Then Helm controller will apply the change, will wait and reconcile. Then it it's in the meantime when like the reconciliation of the Helm release was running, right? And in the meantime, like because of what the reconciliation of the Helm release does, it will trigger another reconciliation. You get even if you don't change, in your scenario, think about just imagine you just change the version, okay? You don't even change anything inside the config map. You
Yeah.
get two reconciliations. The second one doesn't do anything because the there's nothing that changed in the source of the release, right? Uh, you have already reconciled the the source revision, right? Which is based on the chart object. So what you are seeing is actually three reconciliations where two provoke an upgrade. And uh yeah, that's what's happening. I'm pretty sure. Do I have a solution? No. I still don't know what to do in this scenario, but I think I understand what's happening
Sorry
in
to
this
make you
case.
repeat, Matthias. So the two are because one is that I change the Helm release object itself. No matter what I change, that will be one trigger. Other is because I'm using spec.chart that will trigger a new Helm chart source. And that is from where the other reconciliation is coming. You're saying.
Yeah, you like imagine you so again, imagine you don't even change the config map, only the version in under spec chart, right?
Mm-hmm.
That will guaranteedly give you two reconciliations of the Helm release. Will both
Mm.
provoke an upgrade? I don't think so. Just the first one, because the first one, so the first reconciliation is what you actually do, right? What did you actually change? It was a Helm release object, right?
Yeah.
Helm controller sees that and does something which provokes another reconciliation of the same Helm release object, which
Yeah.
is changing the Helm chart um, object. So, well, one thing you can do, yeah, that wouldn't solve the problem anyway. Like if you instead of spec.chart, you still get two reconciliations that will change something in the release. So it won't, I think even if you change from spec.chart to spec.chartref to avoid this, because we're here spending time on me explaining you the magic of Helm release generating a Helm chart object, which is something we
Mm.
don't like and have been trying to move away from. That's why we have the new field spec.chartref, where it works just like a customization. Like a customization has spec.sourceref, right?
Yeah.
It's so once if you want to apply a customization in Flux, you have two objects, the source and the customization. With spec.chartref in the Helm release API, we achieve the same, right? But I don't think it solves your problem because uh if let's say you had a Helm chart object or an OCI repo chart, uh, let's say in the same file, I mean, applied by the same customization, right? Like you're changing the version on one object, you're changing something else in a config map. you will still get two reconciliation events in the Helm controller for that Helm release. So you can try, like you could try to, I don't I don't think it will work, but try to extract your spec.chart field into
Mm,
a Helm chart object and reference that object with the spec.chart ref field.
okay. Okay.
Try to do that. I don't think it will solve it.
One question, that will happen if the source is an OCI repository. Will that happen as well?
Yeah, I guess it would happen as well.
Yeah.
Because what we're talking about here is that at the end of the day, Helm controller a Helm release
Mm,
refers to a source, either directly or indirectly, right? Like when you're using spec.chartref, you're directly referring um, to a source chart. It can be a Helm chart or it can be a OCI repository. This means that the Helm controller will watch for that source object, OCI repository or not. So you're
Mhm.
gonna get events that will trigger the Helm release from that. And um,
Yeah.
from when you're using spec.chart and not spec.chartref, you're
mm,
still referring to a source, but one that you create yourself, right? The Helm
Mhm.
controller creates that Helm chart object. Um, but but just as I looked in the code here, like it's literally like we have a switch case where the first case covers chart ref and the second case covers spec.chart. So uh so either way you are watching a chart. And the reason for why spec.chart does not trigger two upgrades is because of the Helm release state machine. It doesn't matter that the Helm release, the Helm controller sees two reconciliations for that Helm release. Like with spec.chart, right? As I just explained, probably hard to understand, but like as I just explained with spec.chart, you always get whenever you change something under spec.chart, you always get two reconciliations in the controller. But because of how the Helm controller state machine works, you only get one upgrade.
mm, I see. But this will not be even solved if we don't use the values from and even put the values directly. Even then, that will cause two upgrades, right?
Yeah, I don't think this will solve it. You can try. I mean, you should, regardless of this problem, you should move away from spec.chart. Anyway,
Yeah.
it's an awful API. Use spec.chart ref, regardless. See if it solves. I don't think it will, but you should be using that anyway.
Okay. Thank you so very much.
Cool. But yeah, this problem is I'll be thinking about it. I don't have a solution right now, but I'll definitely be thinking about it. It's it's very relevant. Any other topics before we wrap up?
I don't think so.
All right. All right. Thanks everybody for coming. See you
Yeah.
next week.
Thank you.
Thank
Thank
you.
you. Take care.
Thank you. Take
Take
care.
care.
Bye.
Bye bye.
Bye. See you.